Hello everyone, welcome to Mathematics Unit 1. This video will focus on the second part of 6C. The learning intention is to factorize the polynomial and to factorize the sign difference of cubes. Okay, so first of all, let's recall what we have learned on the first part of the 6C, the factor theory. The factor theory, so for a polynomial p of x, so that p is short for polynomial. If p of alpha equal to 0, then x minus that alpha is a factor of p of x. Now, conversely, if x minus alpha is a factor of the polynomial of x, then the p of alpha is equal to 0. Okay, so all this definition may sound confusing for you, or you have no idea what this theory is talking about for the definition. Okay, don't worry, we're gonna continue to do more example to help you to understand the application, and then through the application, you will understand the factor theory a little bit more. Okay, so now we're gonna start with example 12. Which is x cubed minus 2x squared minus 5x plus 6. So we are asking you to factorize it. Okay, so now if you have a look about this constant term, so which is we are looking for the factor of 6. Okay, so you will have plus minus 1, plus minus 2, plus minus 3, plus minus 6. All of them are the factor of 6, the constant term. And that's how we usually try to, that's where we usually start, okay, to find that factor. Okay, because you see, go back to our factor theory on the left hand side. P of alpha equal to 0. So we are trying to look for that particular value of alpha to make p of alpha equal to 0. Okay, so now all of this factor of your constant term could be potentially that alpha. Okay, so we're going to try one by one. Usually we try from the smallest to the largest. So let's try p of negative 1. Okay, so now in this case when alpha is equal to negative 1. Okay, so p of negative 1. So we're going to substitute that negative 1 to my equation, not equation, the polynomial. So therefore, I'll have negative 1 cubed minus 2 times negative 1 squared minus 5 times negative 1 plus 6. Okay, so you have negative 1 minus 2 plus 5 plus 6. Okay, then this apparently is not equal to 0. Okay, so therefore, p negative 1 is not equal to 0. So this this is not what we're looking for. Then we need to try one more. So the next one you can try is 1. Okay, so if you substitute 1 back to your polynomial, you have 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. Then you have 1 minus 2 minus 5 plus 6. It actually equal to 0. Okay, which is what, so this is saying p of 1 equal to 0. Okay, so because our factor theory says p of alpha equal to 0, then x minus that alpha is a factor. Whereas for our case, p of 1 equal to 0, so therefore x minus 1 is a factor of p of x, which is x cubed minus 2x squared minus 5x plus 6. Okay, so now so now we know, and let me use a different color. So now we know x minus 1 is the factor of p of x, which is our polynomial. Okay, so when we find the first factor, now you can use the denom division to find other factors. Okay, so then we can use the non-division x minus 1. Okay, so in this example, I'm gonna try to explain the non-division procedure again very slowly, and for the rest of the example, if we come to the non-division, I'm gonna jump very quickly. Okay, so now let me do that one more time to help you to recall the procedure of doing non-division. So you see, 9 divisor is 2 terms. Okay, so that's why we're gonna focus on the 2 terms, the first 2 terms of your dividend. Okay, so we're going to focus over here. Now, what we do next is we're going to use, so you see the highest power term over here for the dividend is x cubed. And we're going to divide it by the highest power term of your divisor x. Then you get x squared. And then we put x squared over here. Alright, the reason why we put x squared over here is because you see here, if I use that x times x squared, I get x cubed. This is what I want, because I want to make it the same to x cubed over here on the top. Alright, so now we do next, negative 1 times x squared, I get negative x squared. Okay, then we do subtraction, x squared minus x cubed minus x cubed, that canceled out. Okay, then I'm gonna use negative 2x over here, x squared, negative 2x squared minus negative x squared minus negative x squared. Then you have negative 2x squared minus become plus x squared. You actually then got negative x squared. So over here, subtraction, you get negative x squared over here. And then you bring one more down, minus 5x. So you have two terms again that match the number of terms for your divisor too. Alright, so we're going to do the same thing. Now your highest power term become negative x squared divided by the highest power term of your divisor x. Then you have negative x. So put that negative x over here. Then you have negative, you do the multiplication. Negative x times x, you have negative x squared. Negative x times negative 1 over here, you have positive, because negative x times negative 1, you have positive x. Then you have that canceled out, and minus 5x minus x, you get minus 6x. And I'm going to bring one more down, so that'll become plus 6. Okay, so we're going to do that again. The highest power term become negative x divided by highest power term of your divisor x, and then you have negative 6. So put that negative 6 over here. Then you're going to do you're going to use negative 6 times your divisor, and then you'll have negative 6x plus 6, and you have 0. Okay, so therefore x cubed minus 2x squared minus 5x plus 6 is equal to x minus 1 times x minus x squared minus x minus 6. Okay, so we have factorized into two different bracket, x minus 1 and x squared minus x minus 6. So these two brackets are the factors. Now, if you have a look about this quadratic over here, x squared minus x minus 6, you actually can factorize more. That will become it will become x minus 1, x minus 3, x plus 2. Alright, for this part, if you don't know how to do it, make sure you check my video, straight B video. Okay, so check my video of straight B, or you ask me in a class how do we factorize further to the one over here. Okay, so now we have finished. So coming back to recall, you see here, your first step is always try to find all the factors of your constant term, and when you find all the constant term over here, make sure you try from the smallest to the largest. As soon as you find the one that equal to 0, then then you use factor theory. P of alpha equal to 0, then x minus alpha. So x minus 1 is a factor. All right. So sometimes this method, sometimes this won't work all the time. So for example 13 on your booklet, we are asking you to factorize polynomial p of x is equal to 3x squared plus 3x cubed plus 3x squared plus 2x minus 5. Okay, so we're gonna do the similar. Alright, so we're gonna find the constant term. So the constant term is the 5 or negative 5, doesn't matter. So 5 So factor of 5. Okay, so we're looking for the constant term, -5. Let me just put the -5 over here. So then you'll have +1, +5. All right, so these are the 4 different factors of -5. Okay, which is the constant term of your polynomial. Okay, so now we're gonna use that. We're gonna try all of this according to the factor theory. Okay, so because factor theory says p of alpha equal to 0, then x minus alpha is a factor. All right, so now we need to find which one will make p of alpha equal to 0. Okay, so we're trying to looking for that alpha. So let's try -1. And if you try -1, then you will have 3 times -1 cubed plus 3 times -1 squared plus 2 times -1 minus 5. Then you'll get 2, I suppose. Then it's definitely not equal to 0. So you're going to do the same thing. Try p equal to 1. That will be equal to 8. Definitely not equal to 0. And then when you try 5, and when you try it, you'll get 580. That's definitely not 0. And then you can try -5, and then you have -190. That's not equal to 0. So you see, we tried all the factor of your constant term. No one works. Okay, no one works. Now, this is the time we need to do the rational root theory. Okay, so on the left hand side of my display, this definition for rational root theory is slightly different with the one that you got on the textbook. Okay, but that's all right. Just have a look about the one that I wrote and see whether you understand. Okay, so rational root theory, if you have a polynomial and like this, this is my polynomial form. Okay, what I would like you to notice this, because you know this is the highest, the coefficient of the highest power term, and we also have a0, that is my constant term. Okay, so if a polynomial has any rational root, they must be one of the form of this. Okay, so factor of a0, which is the constant term, so factor of the constant term over factor of an. An is the coefficient of the highest power term. Okay, so you are probably very confused about this definition for rational root theory. That's all right. Let's use example 13 again, the example to help you understand. Okay, so back to example 13. So you see here, we tried all the factor of constant term, and no one matched the factor theory. Okay, so now we have to try the rational root theory. The rational root theory is any root has to be in this form. Okay, so then write it in this form. Okay, so let me write this form: plus minus factor of a0 over factor of an. Alright, so let me just write it down. That will be equal to positive, negative. Now, what factor that I have? Factor of a0. So I know a0 is 5. Okay, so a0 is 5, the constant term. So the factor of 5 can be 5 and it can be 1. Okay, that's all the factors of the constant term a0. Now, on the numerator, factor of an is the coefficient of the highest power term. So on my case, highest power term, the coefficient is 3. So the factor of 3 is 3 and 1. Okay, so now that tells me all the possible rational root is positive negative 5 over 3. So 5 over 3, positive negative 5 over 1. Okay, so 5 over 3, 5 over 1. And it can also be, let me use a different color, can also be positive negative 1 over 3, positive negative 1 over 1. Okay, so then if you simplify, you'll have positive negative 5 over 3, positive negative 5, positive negative 1 over 3, positive negative 1. And you see, we actually already tried 5, positive negative 5 before for the factor theory earlier, and we also tried positive 1 and -1. So no one work. So therefore, we need to try positive. We need to try p of positive -5/3, or we try p of positive -1/3. All right. So if you give it a go, you will see actually p of -5/3 is equal to 0. Okay, so now you see here, this is a fraction. Okay, so back to our factor theory, then this is the time we need to use the general factor theory definition. Okay, so let's have a look on the left hand side. General factor theory: if p of -α/β equal to 0, then beta x plus alpha is a factor of p of x. So in this case, it's really important for you to identify what is the value for alpha, what is the value for beta. Okay, so now come back to the example 13 on the right hand side. So this is my p. So we find -5/3 equal to 0. Okay, so now this match my factor theory. Okay, so now, because in my factor theory, we say if p of -α/β equal to 0, then beta of x plus alpha is a factor. Okay, is a factor. Now compare the two, then you will see, because they both have negative over here, so that doesn't matter now. Therefore, because it's alpha over beta, so that's 5 is my alpha, that straight is beta. Okay, straight is beta. So therefore, alpha is 5, beta is straight. Okay, so therefore, you see beta of x plus alpha is a factor. So therefore, straight x plus 5 is a factor. Okay, so this is how you find the factor by using the general factor theory. Alright, so now we have found 3x plus 5 is the factor. Now this is how you do non-division. Usually you have straight x cubed plus 3x squared plus 2x minus 5. Okay, and then you do the non-division by the factor you just find out. 3x plus 5. Okay, you have fixed first two terms, so we focus on the first two terms. And then after you do non-division, and then you will have x squared plus x minus 1. All right, so after you finish everything over here, now so therefore straight x, but in your working out, make sure you show the non-division process over here. Okay, so now we have dividend 3x cubed plus 3x squared plus 2x minus 5 is equal to straight x plus 5. That's one of my factor, and the quotient times another factor x squared plus 1 plus x minus 1. All right, so on your textbook, we told you this one can be factorized further by using completing square. Okay, so if you not sure how to factorize how to completely square over here, please make sure you ask me. Okay, but if you have a look at your textbook, eventually you will get 3x plus 5, and the quadratic can be refactorized by using complete square, and then you get x plus half plus square root 5 over 2 times x plus half minus square root 5 over 2. All right.